Hey everybody, I hope that you're doing well. So last class, we started talking about plotting lines and equations of lines. This class, we're going to dive deeper into a piece that is strongly related with some characteristics of the line that we're graphing, and also ties in these equations of lines very strongly into word problems. Although we'll just use some specific words to connect them today, we won't actually do any connecting to word problems. We're just going to talk about slope. Okay, so the first question is, or the big question of the day is, what is slope? Now, I usually do this big deal talking about it and get someone to finally say that slope is basically just a rate, a ratio, a comparison of two things. But before we go there, let's just talk about what we know about slope, okay? It's going to describe the change of a line from left to right, okay? The change of a line. This is a very powerful word for applying slope to things. It's the rate of change. Slope is the rate of change, okay? And I say from left to right. So from left to right, the line can either go up from left to right, or it can go down from left to right. And so these things are going to tie in strongly with the slope. If it's going up from left to right, you can guess it's a positive change or a positive slope. If it is going down from left to right, it is a negative change or a negative slope. Okay. We've often described slope as rise over run, because what this is describing is the change in the y values, the rise, compared to the change of the x values, how it's changing left to right. So it is going up as it is going left to right, the rise compared to the run. Okay. Now the other kind of characteristic is, if we're just visually talking about the graph, it will describe the steepness. So if I have a really, really high positive slope, my line will look very steep, going up from left to right. If it has a very, very small slope, it's barely moving up or down. Okay, so the steepness. Alright, now, this idea of rise over run, let me get a blank paper and write it another way. So we usually write it like this: rise over run, or rise divided by run. Okay, now, this leads us to the formula, because I just told you slope was change. So this is the change in y values, in y's, and this is the change, the run is the change in x's. And this is easy to remember whether y or x goes with the rise or the run, because rise rhymes with y's, and you run from your x's. Okay. So this leads us to the formula, because how do I find a change from one value to the next? That's just a subtraction. Like if I asked, how much have you grown since you were, 4 feet tall? And you'd say, well, I'm 6 feet now. 6 feet minus 4 feet is 2 feet. So to find a change, we subtract. So what we're going to do is subtract y values. Now, if I just write y minus y, you're not going to be able to tell which value is which. So we give them a little number at their bottom, a subscript to name them. So this is the y from point number 2. This is the y from point number 1. On the bottom of this equation, we're going to do a change in x's. And the important thing here is to keep it in the same order. The x from point number 2 and the x from point number 1. Subscripts in math just name something. So these are the xy pair from point number 2, the point that we named point 2, and these are the xy pair from point number 1. So I can use this formula of just subtracting y's, subtracting x's, and then dividing to find the slope. And all this takes is, all you'll need is 2 points to find the slope. All you need is 2 points. Because if I have 2 points, I have 2 y's and I have 2 x's. So let's see if we can find the slope given a few different setup, or given some points. Find the slope. Let's see. So let's go with 2, -3 is a point, and 1, 5. Okay. Now, if I want to find the slope, the formula for slope is, remember, the y's get subtracted over the x. This is being subtracted. the change in y's divided by the change in x's. Now, so that means I need to know where to stick these points, and I have to be able to tell apart the x's and the y's and the point 1s and the point 2s. So we'll lazily just call this point 1, and we'll call this point 2. It does not matter which one I call point 1 or which one I call point 2. Okay, and then let's label these. Remember last time I told you the reason they're called ordered pairs is because they're in alphabetical order. So that means each one is x, then y, x, then y. And since these are point 1s, they're x1 and y1. And these are point 2s, they're x2 and y2. So I should be able to find the slope from this. So it's just going to be a subtraction and a subtraction. So subtraction of the y values. The formula says y2, which is 5, minus y1, which is negative 3. So the thing most people miss is being very careful with these signs. I go ahead and put subtraction signs there and then put in the numbers that I see so that I won't mess any of this up. So then x2 goes here. x2 is 1 minus, and x1 is 2. So there's what I have. The only part that looks sketchy is minus a negative. Remember, minus a negative is the same thing as adding a positive. So that's all I want to do is if I do have any minus minuses, change them to plus pluses. So 5 plus 3 is 8, and 1 minus 2 is negative 1. So does that reduce any? Well, 8 divided by negative 1 is just negative 8. So there, I found the slope. Let's do another one. One more of these, just for good measure. Okay. So let's find the slope of a point like this, negative 3, negative 4, and let's go with negative 1, negative 10. Now these can be fractions. For some reason I was really lame and made them all whole numbers. I do not know why I did that. Let's name these x1, y1, x2, y2, just to make it easy to tell them apart for our formula here. And let's stick them in our formula. So it's the subtraction of the y's over the subtraction of the x's. So y2 is negative 10, and y1 is negative 4. On the bottom I have x2, which is negative 1, and x1 is negative 3. So be very careful doing this. If you'd like, you can do the top, type that in exactly as you see it in your calculator, and if you do type it in a calculator, I believe you will get negative 6. And the same thing on the bottom, 1 minus negative 3. You can type exactly in a calculator like you see it, 1 minus negative 3, and that will give you a positive 2. And then you need to see if your fraction reduces. Negative 6 over 2 actually is just negative 3. Once again, they can be fractions. I'm not sure why I did a bad job of making examples and making them all pretty whole numbers, but I apologize. They can be fractions. Don't panic. Okay. So now, as far as finding slope, we need to consider two special cases of slope, okay? So here's what I mean. Let's say I'm looking at a nice, beautiful line here. So there's a coordinate grid. And let's say I want to know the slope of this line. Okay, this is a vertical line. And so if I ask you the slope of a vertical line, the easiest way probably to find it would be to just choose 2 points. Let's say that we have the point 4, 1 and the point 4, 3. And let's see if we can find the slope. Okay? So let's name them x1 and because that's all I need is 2 points off the line to find slope, right? So let's call these x2 and y2, x1 and y1, and let's find the slope. So let's see. It's a subtraction of the y's, so 3 minus 1, over the x's, 4 minus 4. And what we will get is 2 over 0. Now, this should be sending red flags off. I cannot divide by 0. Okay, whenever we divide by 0, what we're going to call that for right now, until we have more understanding, we're going to say that is, well, not equal to, because I'm fixing to write a word. We're going to say, oh, the slope is undefined. Okay, it is not equal to a number. So slope is undefined. You can just tell me undefined. Slope is undefined. So this is actually true for any vertical line. So all vertical lines. have undefined slope. Okay, so if I ask you for the slope of a vertical line, you don't have to do any work. You can just tell me, hey, that's undefined. Okay, now let's do the other case. What about horizontal lines? Is that going to be special as well? Well, why don't we do the same thing to explore and discover? So let's draw a beautiful horizontal line and pick 2 points off of it. So we'll go with the point 1, 3, and this point we'll say is 4, 3. And of course we want to name our x1 and y1 and our x2 and y2. So all horizontal lines are going to have some sort of type of slope. Let's see what that slope is. So we got to subtract the y's over subtract the x's. Let's see. 3 minus 3 over 4 minus 1. This is going to give us 0 over 3. Having a 0 on top, that's okay. I can't put a 0 on the bottom, but a 0 up top is fine and okay. 0 divided by 3 is just 0. So, that's fine. That's a number. All horizontal lines have a slope equal to 0. This should make sense, though. Think about this. I told you that slope describes how steep the line is. If it is a flat horizontal line, is this any bit steep? No, it's 0 steepness. It's as unsteep as you can get. It is flat. So it has 0 slope. Okay. Now I will go ahead and tell you, on the test, they love this question. I don't know if they'll have it on the question this year or not, where they love to give you 4 lines and ask you which one has positive slope, which one has negative slope, which one has 0 slope, and which one's undefined. So they ask you to identify the positive, the negative, the 0, and the undefined. Okay? Well, we already know left and right has 0 slope, right? Up and down, straight up and down vertical has undefined slope. Remember, we read slopes from left to right. I said slope describes the change. If you go back and look at the beginning of this video, from left to right, this one's going up. So that's an increasing. That's a positive slope. And like we read from left to right, this one's going down. That's a negative slope. That's a question they love on the test. Usually not worth many points, but it's one they love to ask. Okay. Now, I just got one more thing for you. I actually don't have to pick 2 points to find the slope of a line. If I have an equation, 3x minus 2y equals 8, I can find the slope by solving for y equals. Because there's a special form of a line called slope-intercept form. Okay? And all I need you to do to have slope-intercept form is just get y equals, or basically solve for y. If you solve for y, what you're going to end up with is you'll get something like this. Y equals some number times x plus some number. Okay? And this form tells you actually 2 things. One of those numbers is the slope. The other number is the y-intercept. That's why they call it slope-intercept form. The number beside the x, oh, let's change colors so this stands out. The number beside the x, that is the slope. So if I get y by itself, y equals, if I solve for y, whatever number is beside the x will be the slope. So let's try this out. Let's see if I can find the slope given this equation. Well, let's solve for y. Is y by itself? No, it has 3x and a minus 2. So I need to subtract 3x from both sides. Now the 3x's cancel. Hey, I said blue. Listen to me thing. And I have a negative 2y equals, and it doesn't matter what order you write these in, 8 minus 3x, negative 3x plus 8. I'll just write it this way. Okay. Now I haven't finished solving for y yet, notice I'm going to need to divide by -2, and I'm going to need to divide everything by -2. When I do that, I get y equals, now what's 8 divided by -2? That's -4. 3 over 2 does not reduce, does it? But what's a negative divided by negative? That's a positive, and that becomes a 3/2 with the x beside it. So the slope, remember, is always the number beside the x after you get y equals. So I have y equals, so that means that's the slope. So if I say, hey, what is the slope of this equation? You would say, okay, I know the slope. The slope is 3 over 2. Okay. Are there any questions on that? So you can always find the slope just by getting y equals, just by solving, which we already know how to do. We already have that skill. All right. Awesome, guys. That's all I'm going to cover today. Make sure you do the worksheet and the My Math app homework. Okay. And then we will keep building. We'll see where we go from here. Y'all have a good day.